So I'm going to run through a few examples, and in fact what I'd suggest you do is perhaps pause me before I do each example so that you can have a go at it, see if you understand the mathematical techniques required, and then you can unpause me and watch my approach to it. Now the first few examples look at the concept of averages. It's useful in business to be able to boil down very large figures, large volumes, large costs, large revenue figures, and actually boil them down to an average figure. So you can identify, for instance, that if your total revenue is £50 million and you know you sold 10 million units, well, £50 million from 10 million units translates to an average of £5 per unit that you're selling your products for. Well, let's have a look at the examples I've got here. So first one, Go Here Railways provide meals for their passengers. They made a total of 1 million meals using a total quantity of 250,000 kilograms of ingredients. What's the average usage of materials per meal? Now this is where you could pause me, have a go at that if you want to. If I look at my solution, now the key with these sorts of averaging calculations is make sure you divide the correct number by the other correct number. It's very easy to muddle the numbers up and to divide the wrong way. Now if we want the average usage of materials per meal, so how many kilograms of material each meal used, now just applying a little bit of logic here, you can see we've used 250,000 kilograms, 250,000 kilograms, and we've managed to make 1 million meals with that. So we're getting far more meals than the number of kilograms used. So logically, each meal is using less than a kilogram, because if they were using a kilogram each, then we'd need 1 million kilograms, wouldn't we? So each meal must be using less than 1 kilogram. Now to work out the average, what I need to do is take the total number of kilograms, the 250,000, divide by the number of meals we managed to get from that, the 1 million meals. Now if you do that on your calculator, 250,000 kilograms over 1 million meals gives me an average of 0.25 kilograms per meal, or quarter of a kilogram per meal, as expected, less than 1 full kilogram per meal. Now that could be useful information, for instance identifying what the cost of the materials per meal are. If we know, for instance, that we pay £10 per kilogram to buy the material that we're using, then at £10 per kilogram we'd be paying £2.50 for the material in each meal. Now the common mistake that students will make in that kind of calculation is they'll divide the million by the 250,000. If you do 1 million divided by 250,000, that will give you a figure of 4. So sometimes students might think, well, maybe it's 4 kilograms per meal, but that would be wrong. What that calculation is actually doing is it's telling you how many meals you get from each kilogram of material. So actually from each kilogram of material we're getting 4 meals, which kind of makes sense because each meal uses quarter of a kilogram. Okay, example number 2. Run-Up Limited spent £210,000 on 700,000 kilograms of material. What's the average cost per kilogram of these purchases? Well, how am I going to do my division here? Well, if I want the average cost per kilogram, so how many pounds did each kilogram cost, I need to take the £210,000 total cost, divide by 700,000 kilograms. Now if you do that on your calculator, 210,000 over 700,000 gives me, well, it gives me a figure of 0.3 on my calculator. Now remember, this is the pounds per kilogram, so 0.3 is 30 pence, isn't it? So each kilogram costs them 30 pence. And you can again apply a bit of logic to the figures you've used here. If 700,000 kilograms cost a lot less than £700,000, then each kilogram must be costing less than £1, mustn't it? Now, in fact, if you look back at the 2 examples we've done so far, one way to remember how to do the calculation is, can you see that in the first calculation we were looking at the usage per meal? So we put the meals at the bottom, and we've just been looking at the cost per kilogram, so we put the kilograms at the bottom. Let's see if we can apply that logic to the third example. Walkdown Limited made 200,000 units in 40,000 labour hours. What was the average time taken to make each unit? So how many hours would required per unit? Now if we're doing it per unit for each unit, we're going to divide in this case the number of labour hours by the number of units. So put whatever it's per at the bottom of the calculation. So 40,000 hours divide by 200,000 units, because we're doing it per unit. If you do that on your calculator, I get 0.2 hours per unit. So every unit they produced took them 0.2 hours. And again, that kind of makes sense because 200,000 units took a lot less than 200,000 hours to produce, so each unit's using far less than an hour. 0.2 hours, now we can express it as 0.2 hours, or if I was to multiply that by 60 minutes, we'll actually work out how many minutes each of those units is using, and 0.2 times 60 is 12 minutes per unit. So we can actually express it, because it's in time terms, we can express it either in hours or in minutes. One thing in your assessments to be careful about is, have they specified which way to show it? And then a fourth example looking at averaging. So Strollaway PLC paid staff £428,750 for 35,000 hours of work. So a large cost figure, a large number of hours. Let's boil it down to an average wage rate per hour. So remember, the per hour is telling us what we put at the bottom of the calculation. So if I take the cost of £428,750, divide by 35,000 hours, because it's per hour. Now you can clearly see here, 35,000 hours cost us an awful lot more than £35,000. So we're clearly paying our staff more than £1 per hour, which you would hope. If you were only getting paid £1 per hour, that wouldn't be a very good wage rate. And if I now do my calculation of £428,750 divide by my 35,000 hours, I get that coming to £12.25 per hour. So a rather more acceptable wage rate than £1 per hour. So those first four examples are looking at different averaging calculations, trying to work out costs per hour or amounts of material per unit. Key again is just make sure you're dividing the right number by the right other number and you're not doing it the wrong way round. Well, the next examples are looking at percentage changes in a figure. So question 5, we've got a cost that's increased from £80 to £100. What's the percentage increase in that cost? Well, there are actually a couple of different ways you can do the calculation here, so I'll show you them both just so you're comfortable with them. Now, one way to do it is to take the end figure, so the end figure here is the £100 the cost had risen to, and then divide it by the start figure. In this case, the £80 that the cost had started at. So if I do it this way, £100 divide by £80. Now if you do that on your calculator, you'll get a figure of 1.25. Now what that 1.25 is doing is showing you 1 plus the percentage increase in the cost. So here 1.25 gives me 1 plus a 25% increase in the cost. So the 0.25 is showing us a 25% increase. If that had been 1.2, it would have been a 20% increase, 1 plus 20%. Because when we express percentages as a decimal, so 25% becomes a decimal of 0.25. Now the other way to do this kind of calculation is to look at the change in the cost. So in fact the change in the cost, well, it's grown from £80 to £100, which is therefore a change of £20, and take that £20 and divide by, and this is the key, divide by the starting point, divide by 80 in this case, because when we work out percentage changes we always do it as a percentage of the starting point. Now that gives me a figure of 0.25, which you can either think of as the same as this 1 plus the percentage increase we saw previously. We just don't have the 1, so all we need to think about is it's the 25% increase. Or the other way you could do it is, because percent literally means parts of 100, if you multiply by 100, that gives me my 25%. So two different ways of arriving at that 25% figure. The key is to look at it as a change on the £80 starting point. So question 6, now here we've got a cost falling. So it was £150, it's fallen to £120. What's the percentage decrease in the cost? Now again, we can do this in one of two ways. So let's start this time by looking at the actual change in the cost. So if it's fallen from 150 to 120, that's a £30 reduction, £30 decrease in the price. To work that out as a percentage, divide it by, and again we always work it out as a percentage of the starting point. So the cost started at 150. Now £30 divided by 150 gives me 0.2, which, to turn it into a percentage, if I multiply by 100, because percent means parts of 100, I get 20% as the decrease in the cost. Now we can do that our other way. In this case we would take the figure it ended up at, which is 120, divided by the figure it started at. So that's very similar to what we did in the previous example. Do you remember we took the 100 that the cost ended up at, divided by the 80 that the cost started at? We're doing exactly the same. It ended up at 120 and started at 150. Just looks a bit different because this time it was a decrease in price. But if you do 120 divided by 150, this time on your calculator you should get 0.8. Now remember, this is showing me 1 plus the percentage increase, or indeed 1 minus the percentage decrease. And 0.8 is 1 minus 0.2, and 0.2 is our 20%, isn't it? So we can look at it in these terms. You've just got to remember that with a decrease in a figure, the figure you end up with will be below 1, and the difference between your figure and 1 will be showing the percentage as a decimal for the decrease. Well, what about question 7? So hopefully you've already had a go at this. Pause me if you want to have a go. We've got price rising from 18 to 20. Well, we can do this in a couple of different ways. We can either take the price that it ends up at, divide by the price that it starts at. Now £20 over 18 gives me 1 point, well, on my calculator I get 1111111111, lots and lots of ones. In fact, the way mathematicians would show you that is they put a little dot at the end of the figure. Now that dot means recurring. It means that 11111 will effectively continue. Now remember, this is giving me 1 plus the percentage increase shown as a decimal. So in this case 1 plus, well, it's 11.11%. But again, it would have lots and lots of ones if I wanted to write it out in full. One thing you'd have to watch for in your assessment with something like this is how many decimal places they want in your answer. So if, for instance, they asked for 2 decimal places, I would show it as 11.11%. if I showed it in any other way. If I just showed it as 11% or 11.11111%, I would probably get marked wrong because I wouldn't be following the instructions. The alternative approach, remember, is we can look at the change in the price. Now 18 to 20 means that the price has risen by £2. I could probably do that without an actual calculation there. And if we take the £2, remember we always divide by the start point. We want the percentage change from the start point of 18. And 2 divided by 18 gives me, and this should look a wee bit familiar, 0.11111111 with a recurring, which you can see is again the same as we had previously, just without the 1. And so if you then multiply by 100 to turn it into a decimal, and again follow any rounding rules they give you in your tasks, that would be my 11.11% if I was rounding to 2 decimal places. Now the thing to watch out for there, students would often look at that example and think, oh well, the price has risen by 2, 2 divided by 20 is 10%, and they would often think that that was a 10% rise. But remember, we always work it out as a percentage of the start point, in this case the 18, not of the end point, not of the 20. Well, the next example is a little bit of a funny one, because the next example is looking at the percentage change on a percentage figure. Because we're looking now at how the interest rate on a bank loan might alter. The government sometimes changes interest rates, and if the government changes interest rates, that'll have an impact on the cost that companies pay when they borrow from a bank. So let's imagine that the government has increased interest rates, so your bank decides they're going to charge you not 10% anymore, but now 13%. What is the percentage increase in that interest rate? Now this is an easy one to misinterpret because the interest rate itself is a percentage figure. And what a lot of students would say is, well, if it's gone from 10 to 13, that is surely a 3% increase in the interest rate. Well, actually, that would not be correct. Because would you agree a 3% increase in something doesn't sound like a very big increase? Whereas to go from 10 to 13% is actually quite a big increase in your interest rate. Now, a bit like we've been doing in the previous examples, there's a couple of ways you can work this out. You can either look at the fact that if it's gone from 10 to 13, that is a 3 percentage point increase in the interest rate we're paying. But to work out what the true percentage change is, we need to divide by the starting point. The starting point is 10% here. If you do 3 divided by 10, you'll get 0.3 on your calculator. And if we multiply by 100 as usual, well, that's actually a 30% increase in our interest rate. To go from 10 to 13 is actually a 30% increase, which is actually quite a significant rise. It isn't just a 3% increase. The alternative approach is to take the figure it ends up at, divide by the figure that it starts at, which in this case 13 divided by 10 gives me 1.3, which is 1 plus the percentage increase expressed as a decimal, and 1 plus, well, 1 plus 0.3 is again a 30% increase in the interest rate. So do be particularly careful if you're looking at percentage changes on a percentage figure. Make sure you do your usual job of dividing back by the starting point. Well, the remaining examples are all looking at use of margin and or markup information to help us identify the cost structure and the profit structure within a business. So if we have a look at the first one has a sales price for a product of £190. They have a target profit margin, so notice they're using that word margin, of 40%. And what we're trying to work out is the maximum target cost they can incur. Now, if they're going to sell a unit for £190, you can imagine they need the cost to be less than £190 if they want to make some profit. But you can imagine if they incurred a cost of, say, £189, which would give them a £1 profit, I don't think that's going to be a 40% margin. So how do we work out this maximum target cost? Well, when you're using cost structures like this, when you're using margin and markup information, quite a useful approach is to just consider very simply the way your profit and loss works, in the sense that you'll have your sales revenue at the top. You'll then be knocking off various costs to arrive at your profit figure. Now we can actually build up the way that the P&L works in a percentage fashion to start with, because we know that the profit margin, so at the bottom of the P&L, the profit margin will be 40%. We then just need to remember what margin means, or what it's short for. I think of margin as being short for margin on sales. So it means that 40%, that relates to the sales revenue. So the sales revenue would be 100%, giving a profit margin of 40% of those sales figures. To get from 100 to 40, the cost being deducted would therefore have to be 60% of the sales revenue. So you can see I can build up a little, almost like a skeleton profit and loss in percentage terms, which I can now use to apply to pounds, because we know that our revenue per unit, the selling price on each unit, is £190. Well, the profit at 40% margin, well, if you do £190, and to multiply by 40%, you can multiply by 0.4. Remember, 40% expressed as a decimal would be 0.4. Now, 190 times 0.4 gives me £76. That's going to be my ultimate profit. If I don't make £76 profit, I'm not going to hit my 40% margin. Now, you can either then work out the cost by doing £190 price less that £76 profit, which is £114, or alternatively, because you know the cost to give a margin of 40% must be 60% of the revenue, you can actually work it out based on the revenue of the 190 times 0.6. 0.6 is how we'd express 60% as a decimal. And you can double check actually, because you can do that either way. 190 times 0.6 is indeed £114. So I reckon in answer to the question, what's the maximum target cost they can incur? Well, it's £114. If they spend any more than that making each unit, so if they make £120 as their cost, then they won't make the profit that they want. Well, the next example, actually also looking at a target profit margin, this time 25%, but this time they've given us the production cost. They spend £150 producing the unit. What must the selling price be? Well, if I put together my little skeleton profit and loss, so sales revenue less costs would leave profit. Now the profit margin this time is 25%, and it's margin on sales. So again, the 100% would be the sales revenue figure, meaning that the cost to make it work, well, to get from 100 to 25, I must be deducting 75% of my costs. So again, I can start by putting it together in percentage terms, a bit like we did with the previous example. Then you can start putting your pounds in. And as we saw in the last example, once you know your percentages, as long as you know one of the pounds figures, so in the previous example, all we knew initially was the £190 price, as long as you know one of the figures, you can actually work out what the others must be. Now in this case, we know the £150, which remember is the cost. That's the cost of producing each unit. How can we therefore work out what the selling price must be? Well, we can see here that the cost is 75% of whatever the sales price is. So whatever your price is, you'd be multiplying by 75% or multiplying by 0.75 to give the cost. Well, to go the other way, to go from the cost to the revenue, we need to divide by 75% or divide by 0.75. Now, if you do 150 divided by 0.75, I get that giving me £200 as what the selling price must be. Now let's see if that works. £200 less £150 will leave me a profit of £50. Let's check that gives us the right margin. Well, £50 profit divided by the revenue of 200. So if you do 50 over 200, remember it's a margin on sales, gives me 25%. So we've seen two examples there using margins, one where they gave us the price and we could therefore work out the cost, and one where they give us the cost, and so we could work out the price. Well, what if we do a similar exercise dealing with markups? Now you're going to see some fairly familiar figures here, so let's be careful we don't model everything up. We've got a sales price of 190, markup of 40%. What is the production cost of the product? Now actually that's not too dissimilar to example 9, where we had a sales price of 190 and we had a 40%. The difference is this is now a markup of 40%. And whereas margin is short for margin on sales, markup is short for markup on cost. Now when I put together my little skeleton P&L, so sales revenue minus costs will leave me my profit. Well, the profit element is still the 40%. What differs here is what that's 40% of. Because it's a markup of 40% and markup is short for markup on costs, the cost this time will be the 100% element. The profit element is 40% of the cost figure. Now what must the revenue be that when you knock off 100% you're still left with 40%? Well, I think it must be 140%. 140% less 100 will leave 40. So again, if you put your little P&L together with percentages first, I can then introduce the pounds. Well, we know that the sales price, so the revenue from each unit, is 190. What therefore will the cost be? Well, you can see the relationship between the revenue of 140% and the costs of 100%. To work out what the cost will be, easiest approach is probably to divide the revenue by 140, because that's how much it relates to, and then multiply by 100, because that's what we need to identify. Now 190 divided by 140 and times 100 gives me £135.71 if I round to the nearest penny. And let's check if that works, because if you take £190 selling price less that cost of £135.71, that gives me £54.29 as profit. And if we actually double check, because we know the profit should be 40% of the cost figure, because with a markup what they're doing is taking the cost and just adding 40%. So if you multiply £135.71 by 40%, or by 0.4 as a decimal, that does indeed give me £54 and, bar a little bit of rounding, the 29 pence. Well, final example, £150 production cost, and again we've got a 25%, but it's a markup of 25%. So I put together my little skeleton profit and loss. Now again, we know that the profit element is the 25%, so this is looking a bit like example 10 initially, but because it's a markup of 25%, the 100% goes in the cost section. Well, what would I be knocking from 100% to give 25%? I reckon the sales revenue would now need to be 125% in order to make that work. We know that the cost is £150. So how can we put together the structure of the profit and loss in pounds terms? Well, again, if you look at the relationship between the revenue and the costs, the revenue is 125, whereas the cost is 100. So if I take the £150, because this time we're going from cost to revenue, if I divide that by 100 and multiply by 125, I think that the appropriate selling price will be £187.50. Now if we check what profit that would leave us, well, £187.50 less £150 gives me £37.50 as my profit, and we know that should be 25% of the cost figure, because it's a 25% markup. And if you work out £150 times 25%, so if you multiply this time by 0.25 as a decimal, you should get the £37.50. So, we've waded through a few examples there, margins and markups. We've looked at percentage changes on figures, and we've looked at averaging figures. Hope you found that useful. Just a matter of practicing those kind of calculations over and over and over again.